So we'll continue now with the structuring systems, the application of basic structural modeling. The introductory video will give you more information about accessing the website here, also the Twitter feed. We'll move right on and look at the basic structural modeling project overview and also the structure of this particular slide deck and the information that we're trying to convey here. So we're going to basically just start with the introduction, which will describe the simple problem that we're using as an example here to basically demonstrate some of the methods and concepts involved. And then and that particular process is an ordering process. So we'll talk about that, and we'll go through in the ordering process. We'll look at the highlights of each step in the ordering process and discuss what they mean. Then the process steps kind of go through quickly each of the individual steps. This video is not designed to go into the details of the process steps, but just to introduce the processes and to discuss what would be necessary to write software to support these processes and methods. Then we'll have a process summary and conclusions about this particular test approach that was reported in this project overview. So what we're doing with basic structural modeling is we're preparing a system that will be able to structure unknown systems. And in this case, we have taken a spatial relationship, which is north of. We've selected 19 cities, and these 19 cities are placed in an unknown, unordered state. So we originally selected these 19 cities, and we knew the order of them. We knew what spatial order the cities were in, but then we randomized those as a test so that we could see whether or not our methods would reproduce the known order. So once we have put the cities into an unknown randomized state, then cities are selected at random to begin with. What that means is we're going and sample the data pool, and we'll collect a few of the cities. Start out with 5 cities, and we'll get 5 data points for each one. And that's the empirical data that will be collected. And then you perform analysis to order the cities based on the empirical data that has been collected. Then we'll also use inference on the ordered data to infer further answers about the order of the cities. And the overall fundamental objective of this type of process is to minimize the amount of empirical data collected and maximize the inference that's used to order the cities. Because empirical data and sampling has a cost associated with it, then you would be minimizing the cost of the activity, the ordering and structuring activity, by using inference. So this is basically a cost minimization type of approach for structuring complex systems. As I said before, we picked 25 data points. That was 5 cities at random and 5 data points associated with each one of those cities. And then we placed those on the matrix chart, and we ordered those cities and performed an inference operation to get some more ordering data. And then we did it again, selected 5 more cities at random, 5 points with each one of those. Then we ordered the cities and did the inference operation again, which gave us now approximately 50 data points that were ordered. And that gave us enough of an ordered basis now that we could start looking at the data and saying, well, now we can pick the data or the city that will give us the highest inference potential, give us the largest payback for getting that specific information. And so the ordering process, again, more specifically, is first, so we identify the cities and create a matrix. And here is the example of that. So we have 19 cities in a matrix. This is a Cartesian coordinate system of these cities on a self-referential matrix. And we have, it's full of zeros because we really have no information about these cities yet, their relationship. We know they exist, but we don't know how they're ordered. And the ordering relation is north of. So we're saying is city 3 north of city 1, or is well, we don't know. We've put a yellow 0 in there. But now we say is city 3 north of city 3, and we have a red 0. And the reason we have red on the diagonal is that is red mean a red 0 means we know that that's false. So in this particular case, we're not going to allow a city to be north of itself. And so all of the entries on the diagonal are known to be false because we do not allow logically cities to be north of themselves. So that's kind of the basic situation you start with. So we've identified the cities, we've created the matrix. Now we'll collect and enter the initial empirical data. So here we've randomly selected some cities, and the scatter plot is pretty much all over the place. So you see that a green 1 means, yes, this is true. We know that city 11 is north of city 2. And this green 1 here means we know city 10 is north of city 4. This red 0 here means we know city 5 is not north of city 1. And you also see that there's a geometric symmetry between a red 0 here and a green 1. That will be across the diagonal this way in all of these particular scenarios. So that's what we've done. We've got the beginning empirical data here, which is 25 green data points. We inferred from that 25 more red data points. All right. Then we analyze and order the cities based on our first set of data. And you can see that in ordering that, now we have all of the green down in the lower triangular. So we've ordered this so that that city 11 is north of city 2, city 11 is north of city 9, city 11 is north of city 14. So we know that these green ones, that these marks, these cities are north of these cities here. The yellow, of course, is unknowns, and the red means that we know, as a matter of fact, that it's not. We'll go back through here, back to the overview chart. We're just kind of moving quickly back through this. So then now that we've ordered the cities, the first batch of data, then we'll conduct an inference analysis, which will give us new information, and we'll also put in new empirical data. So we'll see what that looks like. Now, the ones in blue, this information was arrived at through inference, and then the green ones out here and the new red zeros, those were arrived at through empirical information. So we now again have green ones in the upper triangular, and we'll want to order those by bringing those into the lower triangular section. So we'll go back again here, and then we'll analyze and order the cities like we did before. And so analyze. Now this is once we have the new set of inference ones in blue and the new set of the second set of empirical data, which gives us 50 data points all put together. And now we have those all in lower triangular form. Now we'll go back and look at how this works again. So then we'll conduct the inference analysis. Now we'll infer more. We've inferred more blue ones here. Okay. Then we'll go back again quickly to the, whoops, went past at that time. And then we'll conduct further, and we'll collect more data one at a time and then do an inference. And as you can see here, we're getting more and more blue ones, so that we're getting the same quality of information through inference as we were getting through empirical data. But the inference essentially is a calculation where the empirical data costs money to actually go sample and find out and get data. So what you really want to do is you want to maximize the use of the inference. And in this particular case, we haven't really done that. This is just a demonstration, but get the idea across. Okay, so now we're going to go back to the beginning again. Look very quickly. Whoa, went past it. Okay. And so then we'll collect some more data, do another inference. And in this particular case, you can see there's a lot more blue. But now we're going to just select the data to get one at a time. So we're going to now, instead of randomly selecting data, we're just going to pick the data points that give us the most inference potential and walk through those. As you can see down here in the lower right hand corner, we walk through those, and those basically then we finalize the matrix and it's complete. The process summary is to basically identify cities in the relationship, start with random selection, execute the ordering and inference process, pick individual data points for data collection, and execute the ordering and inference processes. Do that recursively. We did it 2 or 3 times here in this process. And so the conclusions were the process test was successful. The known order was reproduced. We took a known ordered set, we randomized it, we sampled the data, we were able to reproduce it. But we use semi-automated steps, and we're going to have to take those semi-automated steps and put them into automated code. And there needs to be tighter code and process integration. The graphics appear to be useful for actually communicating what's going on. And now we're just going to go on to detailed code design. And that's kind of it for this first run and first walkthrough. And again, the website's here and the archive is here.